Everyone, just a quick video going over the answer key to these 5 extreme value theorem problems from Desmos. So go through these. For number 7, we're asked to find the maximum and minimum values of a function. Remember, a function can have its absolute maximum and absolute minimum values at the endpoints of an interval or at points where the derivative is equal to 0. So if we find the derivative of this function, we end up with -2 cosine x times sine x plus sine x. If we set that equal to 0, we can factor out sine x. And we'll eventually find that our x values are from sine x equals 0, which gives us x equals 0, or -2 cosine x plus 1 equals 0, which gives us x equals pi over 3 and 5 pi over 3. But 5 pi over 3 is not in our interval, so we're not going to use that one. So we want to find f of 0, one of the endpoints, f of pi over 3, and f of 3 pi over 2, the other endpoint. When we find these values, we find f of 0 is 0, f of pi over 3 is -1/4, and f of 3 pi over 2 is 2. So our absolute minimum value is going to be -1/4, and our absolute maximum value is going to be 2. Here we're given a piecewise function. We want to find out which of these statements are true. Statements are asking about absolute maxes and mins. So again, we know that a function is going to have its absolute maximum and minimum at an endpoint or at a critical number. So if we find the derivative, we find that the critical number, where the derivative is going to be equal to 0, is just 0. And also at x equals 1, where the derivative doesn't exist, that's also going to be a critical number. So we want to find endpoints, which are 0 and 2, and also critical numbers, and evaluate the function at those critical numbers. So f of 0, we're going to plug 0 into the top piece. 0 squared is 0. For x equals 1, that gets plugged in the bottom piece, gives us 0. And when we use x equals 2, that gets plugged in the bottom piece, also gives us 0. So we have no maximum value. So this statement's not true. The biggest value we have and the smallest value we have are just 0. So we do have an absolute minimum of 0. Again, if we had an absolute maximum of 1, that would have shown up at one of the critical numbers or at one of the endpoints. So this is not true. We do not have an absolute maximum value of 1. And in fact, this does not contain an absolute maximum value. If we look at the graph of this, it makes it a little bit clearer. X squared we know is a parabola. We have x squared from x equals 0 to 1. But at 1, we're not using that point. And then from x equals 1 to 2, we have just y equals 0. So you can see from the graph, there is no maximum value. We can get as close to 1 as possible, but we'll never get to 1. You might say the maximum value is 0.9. Next person says it's 0.99. Next person says it's 0.999. You could do that forever, never getting a maximum value. You can see the minimum value, though, is in fact 0. Find the minimum velocity. They're giving us a velocity function. Again, to find the minimum value of a function that's going to occur at one of the endpoints or at a critical number. So for this function, I just rewrote v of t as 2t squared minus 14 plus 20, just distributed, FOILed, and distributed. Found the derivative, found a critical number of 7/2. So we want to find the velocity at each of the endpoints, 0 and 6, and also 7/2. You plug 0 into the velocity function, you end up getting 20. Plug 7/2 into the velocity function, you get negative 9/2. If we plug 6 into the velocity function, we end up getting 8. So our minimum velocity would be at negative 9/2. The fact that it's negative means it's going to be moving down, but also if we just look at the speed, it's also the smallest value, has 4.5 versus 8 or 20. So our minimum velocity is going to be the negative 9/2. For number 10, we want to find the time at which a particle is farthest to the right. The position is given by this x of t, so we want to find when this x of t has a largest number. If the particle is moving along the x-axis, then farthest to the right means we want the largest x value. So looking for the maximum value of this function. Again, it has to occur at 0 or 2 pi, one of the endpoints, or a critical number. So we're going to find a critical number of this function. So if we want to find critical numbers of this function, we find the derivative, set it equal to 0. For the derivative, you need to use a product rule. We end up with this mess. If we set this equal to 0, obviously e to any power can never ever be 0. The only way that this derivative could be equal to 0 is if sine t plus cosine t is equal to 0. This will only happen when sine and cosine have the same absolute value but different signs. So at 45 degrees or pi over 4, sine and cosine are both equal to root 2 over 2. But in quadrant 2, sine and cosine have different signs. So the root 2 over 2's would cancel out. And in quadrant 4, at 7 pi over 4, we have the same thing. So our endpoints are going to be 0 and 2 pi. We want to test those, and we also want to evaluate the function at the critical numbers. So these numbers get a little bit ugly. For x of 0, if you plug a 0 into this, cosine of 0 is 1. E to the 0 power is also 1, so 1 times 1 gives us 1. If we put 3 pi over 4 in here, we end up with the cosine of 3 pi over 4, which is negative root 2 over 2, times e to the negative 3 pi over 4. For 7 pi over 4, the cosine of 7 pi over 4 is root 2 over 2 times e to the negative 7 pi over 4. And for 2 pi, cosine of 2 pi is 1, so we end up with e to the negative 2 pi times 1. Plugging these values into a calculator, obviously if we're looking for the maximum value, it's not going to be this negative number. These other numbers are also going to be very small, 0.00289, and e to the negative 2 pi is 0.00186. So obviously our largest value is 1. And they want the time the particle is farthest to the right. So it gets farthest to the right at t equals 0. The farthest distance is 1, but the t equals 0 is the time at which gets it farthest to the right. All right, for number 11, we're looking for the maximum acceleration. They give us a velocity. We can use the velocity to find the acceleration function. But once we have that acceleration function, we want to find the maximum of that acceleration function. So we find our acceleration function is 2t squared minus 8t plus 8. This is the function we're finding the maximum of. So again, maximum is going to occur at endpoints or at critical numbers. So we want to find the critical numbers of the acceleration function. So we're going to find the derivative of acceleration and find out when that derivative is equal to 0. and that happens at t equals 2. So maximum acceleration occurs at either one of the endpoints, 0 or 3, or at a critical number, in this case 2. So we want to find acceleration at each of those values. Remember to plug 0, 2, and 3 into the acceleration function. This is a function we're looking for the maximum value of. So if you plug 0 in there, you end up getting 8. If you plug 2 in there, that gives you 8 minus 16 is negative 8 plus 8 is 0. If we plug a 3 in there, we get 18 minus 24 is negative 6 plus 8 gives us a value of just 2. So the maximum acceleration is 8. And that's it.